All right, the next example. Well, again, what's the first thing we always want to do? We always want to check to see if there is a GCF. So in this case, is there a GCF? Oh, yes, there is, because look at 12 and look at -3. Is there a number that will go evenly into both of these? Yes, and that number is 3. 3 goes evenly into 12 4 times, goes evenly into itself 1 time. Okay, so let's go ahead and go through our first step here, which is just the factorization of the GCF. Notice you don't have another x here and you don't have another y. So this is the GCF, just 3. All right, so 3 times what? 3 times 4x squared will give you back to where you started. And then 3 times what? -y squared will get you back to where you started here. Okay? Are we finished yet? No. This is, as some of you may know it, a difference of 2 squares. Difference 2 squares. And there is a special formula for that. The difference 2 squares will yield the product of 2 binomials. All right, so what's the formula tell us? Well, first of all, recognize this is a perfect square. This is also a perfect square. What's the square root of this? 4x squared. The square root of this would be 2x. You're going to put a 2x in the first position of each of these 2 binomials. What's the square root of y squared? It's y. So you're going to put a y in the last spot of each of these 2 binomials. Then all you have left to do is alternate the signs. So, completely factored. All right, the next thing we want to do is revisit the factorization of a trinomial. So, of course, not every trinomial will be able to be factored based upon a special formula. So, this is all just the formal notation for factoring a trinomial. You don't need to know this unless you really want to. But let's go ahead and look at the first example. And let's play with this. Now, some of you could probably just look at this and write down the answer, okay? Because this is just a trinomial that contains a 1 as the leading coefficient. There's an understood 1 here in front of the x squared. That'll make this one easier, all right? So some of you could probably just write this down already, like the quantity of x minus 7 times the quantity of x plus 3. Done. And how'd you do that? Well, you looked at the factors of 21. And let's see, what 2 factors of 21 would give us, or excuse me, 2 factors of -21 would give us a -4 when we added them together. Well, the 2 factors would be a -7 and a +3. -7 times 3 is this. So that's what you'd put inside of the factorization. Now, if you can't do it like that, one other technique is to write down the constant term. So -21, and then think, what 2 factors of this -21, I just told you, would when added together give you a -4? Well, that would be a -7 and a 3. Now, I'm going to probably, again, spend a lot of time on this, maybe too much time on this, for this particular example. But the technique is something that many of you may like. All right, so the process or technique here that I'm going to go through right now is something that'll work for any factorization of any trinomial. Okay, so here's what I'm going to do with these 2 numbers. I'm going to use them to rewrite this trinomial. So check this out. I'm going to change this -4x into -7x plus 3x. So again, what I did was I came up with the factors of -21 that when added together give me a -4. And then I use them to rewrite my linear or middle term in this trinomial. Now what I'm going to do is a process called factoring by grouping. So I'm going to look at the first 2 terms and then the last 2 terms. And I'm going to use the GCF again in order to ultimately factor this by grouping. So what's the GCF of these 2 terms? It's x. So I write x times the quantity of x minus 7. This would give me that, right? Okay, now I look at the last 2 terms. What's the GCF of the last 2 terms? Well, plus 3. And you'd get x minus 7 again. Again, x minus 7. That's important. These two must be the same, otherwise you cannot factor by grouping. So the last step is to do the following. Whatever is in front of the identical binomials, you will now group them together as its own binomial. And then the two identical binomials, you will just write down one time. And you're finished. This is the complete factorization of this trinomial. Again, I know this was probably overkill in terms of the time required to explain it, but what if you ended up with maybe one like this? Well, this one may not be so straightforward in terms of just looking at it and spitting out the answer. Quantity 5x plus 3 times the quantity 7x minus 4. Okay, whip-de-doo. All right, doesn't matter if I can do this, you got to be able to do this. All right? So let's try that same technique again. But this time it's a little bit different. Why? Well, because now you have a leading coefficient that's not 1. That's why this is more challenging, obviously. So the leading coefficient here is 35, and the constant's negative 12. So in this situation, what are we doing? Well, we have to multiply the leading coefficient, 35, times the constant to get us to a value in which now we can come up with factors of, to hopefully, when we add the two factors together of this, hopefully we can come up with a plus 1. So the only difference in this technique for this particular problem is I had to multiply the constant term by the leading coefficient, since it's not 1. But everything else I'm going to do is exactly the same as what I did in the previous example. So what am I doing? What did we do in the previous example? What two factors of this value, that's an interesting number, isn't it? What two factors of this number, when added together, would give you a plus 1? Well, I believe negative 20 and 21 would work, right? And, you know, you can use your calculator. You can play with your calculator as well. Just type in negative 420 or just 420, and then keep dividing by numbers, maybe 2, maybe 4, whatever, and see until you get to 20. Oh, that works, right? 420 divided by 20 gives me 21. Now I can see, oh, the difference here is 1. That's what you want. The difference here has to be plus 1. Okay, so let's go ahead and rewrite this using this information. So 35x squared, then what? Minus 20x, and then plus 21x, and then minus 12. Again, this has to equal the middle term. Now all we're going to do is factor by grouping. Okay, so we have first two, we have last two. So GCF of the first two. Let's see, the greatest possible number that would go in evenly into both of these would be a 5. Then we also have an x in common. So x to the greatest, that's wrong. X to the smallest exponent is going to be part of our greatest common factor. So that's an x. So 5x is the GCF for these two terms. Then we get a 7x, right? And then minus 4, okay? When you multiply, when you distribute this 5x or this quantity, do you get what you started with? Yes. All right, last two terms, GCF. I believe it's just going to be plus 3. Let's see if plus 3 will work. And why do I ask that? Will plus 3 work? Well, when you write down what has to go in parentheses here, it must equal the 7x minus 4. Otherwise, it's not going to work. Well, let's see if that makes sense. Let's see if it works out. So 3 times what will give us 21x? 7x. 3 times what will give us a negative 12? Guess what? Negative 4. They are identical, so it works. So let's finish the process now. What do we do? Whatever is in front of the identical binomials, you group those together, and then you just write down this binomial once, the one that is repeating. And you're finished. It's not necessarily an easy thing for a lot of people. I mean, factoring is something that takes a lot of practice. But if you have any questions, concerns, definitely reach out to me.